Hey, this is Patrick. In this video, I'll be introducing you to PVLB, a server load balancing solution. The total requirements are 2 or more small Linux servers and a DNS service that does some health checks. This example, I'll use a Ubuntu 12.04 server and a CentOS 6 server, which is sort of equivalent to Red Hat, just to show that it works the same on both flavors of Linux. And Amazon Route 53, which in this configuration costs about $3 a month. Why use PVLB solution? It's economical. It requires 2 small servers and a $3 a month service. It's easy. You set up 2 servers with a chef recipe, which is sort of a script, in a few minutes with Chef Solo. It's safe and will stand the test of time. It uses open source software that is widely used and documented: Linux, Nginx, and HAProxy. It's flexible. You modify the configuration to suit your needs exactly. You have the full power of Nginx and HAProxy. And yes, that includes server stickiness. The only part that isn't open source, the DNS with health checks, is in the $3 a month range, and several providers can do it, such as Amazon, DIN, Zone Edit, etc. Now, what if you don't use PVLB? You can use some expensive and complex hardware load balancers. We're talking about thousands of dollars monthly, which usually provide you with less control, less flexibility, weird bugs, and sometimes server stickiness doesn't work well. It's often more complex. You often have to handle some network translation rules, or you can do your own Nginx and HAProxy setup, which might very well be equivalent, except you have to do it. Here is a diagram of how it works. See, you call www.yoursite.com, which is a CNAME to a special DNS entry which has health checks, here in the example lb.yoursite.com. The health checks will check for the 2 HAProxy, Nginx, load balancer, PVLB servers. And if one of them doesn't work, it takes it out the DNS. And in turn, the servers, once they get the request, will forward it to one of the web servers. Now, some design comments. I use Linux, which is 60% market share for internet servers. Nginx has an HTTP proxy. That's 35% of the top 10,000 sites in the world. HAProxy for the load balancing part. This is used by Twitter, Instagram, etc. So it's very reliable. And I combined both Nginx and HAProxy. I use DNS for failover. Just about everyone uses it. And for the configuration, I use Chef Solo. It's just an easy way to build a server from scratch and generate some configuration files. I did a Chef intro video here. You can click and look at it if you want to learn more about Chef. Let's go through the setup steps. We will launch 2 servers for load balancing, launch 2 web servers to serve something, configure the load balancing servers, configure DNS, and smile. Special effect! Welcome to my Amazon console. I've actually launched 3 servers instead of 2 for the load balancing. This is so I can even show you a real Red Hat server and a CentOS and a Linux Ubuntu. The 2 web servers are just dummy web servers that say I am Web 1, I am Web 2, so that's kind of irrelevant. See, LB1 is a Red Hat 6, whereas the 2 others are Ubuntu for LB2 and CentOS for LB3. On my local machine, I made a special SSH configuration. See, the IP addresses are the right ones with the specific logins and the right SSH key. And that way we can log into the servers just with their name as a symbolic thing. I'll just SSH LB1, and it works with the right login. I have an empty TMP directory, and I'm cloning now the repo, github.com/patrickviet/pvlb, so that I can slightly edit it, configure it. and that will be our setup. Let's go into it. Actually, I'll go on to GitHub to show you its content. Here we go, github.com, Patrick Viet, PVLB. The main configuration directories in cookbooks, PVLB, attributes, it's default.rb. Let's edit it now. Cookbooks, PVLB, attributes, default.rb. You see the default configuration. I'll change it to only 2 web servers here. Delete these 2 others. Only leave 1 website with the right web servers. I'll call it very originally PVLB test. Second one, example, just get rid of it. And now the mapping from site to the actual vhost names. I put the same name, PVLB test, and put an actual real website, pvlbtest.com. Here we go, just delete everything. And change the password. Default one is super secure. We'll put another one that's just as secure, PVLB. I haven't put the IP addresses of the servers yet, the real IP addresses. I'll go and get them from the Amazon interface. Here we go, copy paste, 1634. The second one, I think it's 35, but I'll double check. Yeah. $35. I'll leave the 20 wait, and we're good. Now it's time to copy that configuration I just made on the first server. So I'll use the rsync command, which is nice because I don't even have to put anything special. I just put the directory name of the server and all the rest will be set in my .ssh/config I did at the beginning of the demo. Oh damn, I forgot to put the git thing. I'll put it for the next one. Now exactly the same one, except I do put exclude the .git directory. We don't have to copy that. There we go. And LB3. Nothing different. Yes, copy. This, so as I was saying, this works because of my .ssh config that automatically sets the right EC2 user and that kind of thing. Let's run this configuration on, we'll start with LB2. It's a Ubuntu, it's the most straightforward. I'll just go in the directory and /install.sh, it starts, and I fade it so that it takes about 2 minutes to run. I'll show you the files it changed, the nginx.conf. See here it created that vhost with the right names that we put. And same thing for HAProxy.cfg. See, auto generated to the 2 right IP addresses of servers 34 and 35. And exactly the same thing on LB3, which is the CentOS from RightScale. It has all the right software libraries. So I can just cd pvlb /install, we already root, not even sudo, sudo. It installs chef, and starts running it. Actually, let's go and see what it does in the GitHub repo. I'm on GitHub. I'll show you the chef recipe. Actually, first the installer.sh. It does apt-get if it does have it, and runs install chef if it's not there. Now in the cookbook, you'll see the recipe, which does an install of Nginx HAProxy, pushes a few files, and here pushes the templates, and checks that the services are running. Here are the actual templates. It's Ruby ERB language, which is a sort of a subset of Ruby. And you can obviously change them if you want to do any kind of fine tuning or anything like that. By now it must be finished. Let's go back. Okay, that worked. Let's go on to LB1, which is the Redhat one, and it's a little bit more tricky. You'll see why. I run exactly the same thing, install, except that as you'll see here, it fails on the Nginx install. See, no candidate version for Nginx, no version specified, no candidate version. What does that mean? It means that we don't have Nginx as a default thing. Look at that. Install Nginx. Nope, not part of Redhat. HAProxy, not part of Redhat. We will, as a result, get it from an external place. We will install a EPL external thing. I'll put that inside in the description. And with that extra thing, EPL, it means we can actually install Nginx. Look at that. Yep, I want to install it. For HAProxy, it still doesn't work that way. It's not even in that repository. They chose in Redhat 6.4 to not do it anymore. That means we actually have to go on to get it outside. So let's go on rpmfind.net and find something. HAProxy, I want 1.4. Here we have a x64 6.5. Good enough. It should work. Copy paste the link. rpm-uvh paste 1.4, and we will have HAProxy, which means that from here I can just run the chef recipe completely normally and it will do the rest of the run. Let's check how similar it is. Yeah, it looks pretty similar. Great success! Oh, and it's Redhat. I must set the firewall rules. For this, I edit the file. It's called etc sysconfig. etc sysconfig IP tables. Yeah, that's it. And see here the line for that accepts port 22. I'll also accept port 80, so we can do some HTTP on here. Save the file and restart IP tables. Perfect. Okay, let's check this on our browser. Just put the IP address in. Whoa, welcome to PVLB default page. And if I type /health, it will say okay because it is okay. Web 2 I configured. I didn't show you how. It's just install Apache, put a page. It says hello, I'm Web 1. It's just for a test. And let's check for Web 2. Hello, I am Web 2. And if I put here /stats, it will actually show me the HAProxy status page, which is pretty nice. In it, you can see Web 1 and Web 2. I'll do some tests. Let's turn off Apache on the Web 1. Servers Apache 2 stop. And see if anything happens. Refresh. Whoa, look at that. It's red. It saw it. It's not in the load balancer anymore. And what if I reactivate it? Does it come back? Let's try. Start. Oh, yellow. It's coming back. And it's good. Now, how about if we stop HAProxy? What happens? I'll try on LB2 here. I stop it. And I'll run the curl command. What's the IP address? And go 224, copy paste it. /health. And oh, not okay anymore. And if I start it again, sudo servers HAProxy start. Run the same command, and it says okay. So, well, that is also monitored, not just the Nginx. Now let's do the DNS setup. I'll open a Route 53 tab, well, in another tab. And add a zone. For the demo here, it will be called pvlb.dnspower.com. That's a domain name that I own. And now I have to set that subdomain with these 4 DNS servers. Let's do that. I just did it while it was fading, while it went watching. Let's check on my servers. That's private, so I'm not showing it. Let's see. Perfect. See, it's delegated PVLB. And you see it is indeed the same thing. We will also add some health checks. That's the whole point of using the Amazon DNS. Create health check. HTTP, put the IP address of the first load balancer. Copy paste it. Paste. That's random PVLB. Path is /health. Here we go, it's created. And remember, I showed you that a little bit earlier. I'll put it in, and it says, okay, if it's not the right return code, not a HTTP 200, it will say it's not okay. I then proceed to add the LB2. Exactly the same thing, different IP address. And I did the 3. Let's now add some DNS entries. I click on create record set. I'll call it load balancer. I'll put a CNAME to that after. Start with the first IP address. Put a slow TTL. TTL is when a record expires. It means it keeps it in memory that long. Weight of 10, that's random. I'll put the same weight for everything. And yes, I want a health check. It's the right IP address. Let's associate it to. And the trick here, read that. When responding to queries, Route 53 can emit resources that fail health check. This means I'm going to add several entries, one for each server, and if ever the health check doesn't work, it will just stop replying it. And since the TTL is only 1 minute, it means it converges in at most 1 minute, on average between 0 and 60 seconds, which averages to 30 seconds. And I'll continue, add the same name, but for the LB2 address. Same TTL, 60 seconds, and so on and so forth. You get the idea. Now I have the 3 entries. I faded to make it faster. Okay. Now I will just do a dig on this name, loadbalancer.pvlb.dnspower.com, and it should reply one of the IP addresses. See, that looks good. And if you look, you'll see it corresponds to one of the servers. It's LB1 in this case. If I do the query again, it will reply the same one, but if I do plus trace, it will do cached. It will do the full query with trace, and it's another one, 224, and 62 again, and now yet another one, 208, so it does cycle through the 3 of them. Does this health check work? Let's check that. I will turn off HAProxy, no, Nginx, on the LB1. I'll also turn it off on LB2. And now we should only get LB3 as an answer. LB3 is 208. Dig trace. So we're expecting 208, and it worked. Now if I stop some other ones, start some others, it should cycle through. Let's try that. Restart it here. Stop it on LB3. Here we wait a little bit, and we're expecting to get LB1 only. Expecting .62. Worked! Isn't that cool? I'll turn everything back on now. You can obviously look at the state within Amazon CloudWatch if you like. Let's see, what was the subdomain I set? I'll check the configuration again. It is pvlbtest.com. That doesn't exist. I made a mistake. I wanted to put pvlbtest.dnspower.com. But nonetheless, if you query the servers directly, they will properly reply. I'll show you that with a curl command. I do curl. I force the host -h host equals pvlbtest.com with the IP address of the load balancer, and using that host, see here, .62, it will effectively reply I'm web 1 or web 2. And if I run it again, it will probably reply web 2 a bit more often, see, because there's a higher weight for web 2. Well, this is so I'll do the update. First, change the default.rb file, add www.pvlbtest.dnspower.com. Here we go. Then I just rsync it to the 3 servers with the rsync command, rsync-av pvlb/ LB1, PVLB. Oh, and this time I won't forget the exclude.git. Just run it. And it's a bit slow. Here we go. One file changed. Do the same thing on LB2. one file change, same on LB3. And now SSH on to start with LB1. CD PVLB and install. Here it's a lot faster because it's only a very small converge. It will just change this one file. See, it just checks, is Nginx there? Yes, it's there. For some reason the Redhat is really slow though on that specific part. Here we go. See, you have a diff, it changed the server name. Look at that. Looks good. Okay, now I'll do the exact, I'll restart Nginx 2. I'll do the exact same thing on LB2. And on LB3, fading. Okay, it worked. Now our next step is the DNS CNAME. I added it off camera. So it's www.pvlbtest.dnspower.com. You can see it here. It's a sort of an alias. See, blah, 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 CNAME, which ultimately goes to the right IP address. I'll show you in the browser. Look at that. It works. Fantastic. Okay, so I might have gone a little bit fast with this DNS stuff. I'll recap. We have pvlbtest.dnspower.com that I set to be a CNAME to load balancer.pvlb.dnspower.com, which is delegated to Amazon. And depending on health checks, it will send us to LB1, LB2, and maybe even LB3. I just did the slide before I decided to put LB3. So see here, you have the dig answers that give you a little bit more detail. You have DNS Power that's handled by these, and then test pvlb.dnspower.com, that's CNAME, and the CNAME says, the server replies, please go ask these DNS servers, the ns blah 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 .amazon, and we get the final answer, which is 54209 or something like that, depending on which server it happens to be. Oh, and one last thing, I would like to show you the how the server stickiness works. We use the developer tools of Chrome, which is like Firebug but for Google Chrome. When I load the page here, I get a cookie, which is server ID. This is actually the configuration. It means that even if you change load balancers, since you're setting that cookie, you will stay on the same load balancer. I'll show you where it is in the configuration. Let's go on to LB1 and look at the file, Nginx HAProxy. And you see it is effectively ccdf something. ccdf. Exactly. Which means that if I reload the page, I will still stay at the same place. Now let's stop, and it doesn't swap except if I stop the server. So let's stop the Web1 server, and it will switch to Web2, then reset the cookie. If I typed it properly, it would be better. Here we go. Reload. Ooh, what's happening? I think I know. We can look at the stats page by going on the CNAME thing /stats. It's admin and PVLB as we said it. Right, it's what I thought. Both servers are down because I've been testing, stopping, starting, and I forgot to start it back. So I'll start the Web2 server back. It should come back right away. Reload. Perfect. Now it's back in. And if I reload this page, I'm Web 2. It worked. And see the cookie. It got the cookie saying I am this one, but it got the other one. If I reload, it will have just twice because the cookie was switched. And that's all. Thank you very much for watching. Please subscribe, comment, like, share. Thanks.